Ever get that sinking feeling, when you think you've squashed the last bug, only for it to like morph into something new, even more devious?
Oh, yeah.
It's like you're playing whack-a-mole.
Totally.
But with lines of code, right? So we're diving into an excerpt today from This Will Kill All Your Bugs.
Okay.
Which, who doesn't want to kill all their bugs?
Right.
To learn some ninja-level strategies for writing, cleaner, more robust code.
I like it.
The kind of code that doesn't come back to haunt you. So our deep dive today is all about kind of shifting that mindset from just being a bug squasher to really being more of a bug preventer, right?
Oh, yeah.
So ready to evolve your coding game a little bit.
Absolutely. I think that's something that, all coders are striving for.
For sure.
Writing that perfect code, right?
Yeah.
Exactly.
And so this excerpt, it kind of starts off by calling out a common pitfall that I think a lot of developers, especially when you're starting out, you fall into. And it's this idea of narrow thinking.
Okay.
Right? Where we get so laser focused on just getting the code to work, for that one specific case.
Right.
That we don't take a step back and look at the bigger picture.
The bigger picture, yeah.
Right. And think about all the other potential scenarios, all the edge cases, all the things that could go wrong.
Right.
And this is something that, I think we've all been guilty of.
Oh, yeah, for sure.
You're under a deadline. You just got to get it to work. But it's like trying to fix a leaky pipe with duct tape, right?
It might seem like a fix at the time, but, deep down, it's not a long-term solution, right? It's going to create more headaches down the road.
Oh, yeah. No, I've definitely fallen into that trap before. The duct tape coding approach.
Yes.
So how do we actually, how do we escape that narrow thinking trap and actually write code that we're not going to like cringe at a year later?
Well, that's the $1 million question, right?
Right.
And the article presents, I think, a really fascinating argument, which is that good code, it's not just about the syntax. It's not just about the logic. It's about adopting this broader perspective.
Okay.
Right? It's about thinking more like an architect designing a building.
Oh, okay. Interesting. So we need to think more like architects, less like coders.
Exactly. Just like an architect wouldn't just, start building a skyscraper without blueprints.
Right.
We shouldn't just dive into code without, having a solid plan in place.
Okay.
Right. And so the excerpt breaks this process down into 4 key steps, for really adopting that architectural mindset when it comes to code.
All right, let's unpack these architectural blueprints for clean code. What's step 1?
So step 1, it all starts with visualization.
Okay.
Right. Taking the time to actually sketch out your solution before you even write a single line of code.
Interesting.
Right. So this could involve, actually drawing diagrams on a whiteboard, creating flowcharts, or even if it's just, jotting down some pseudocode in a notebook, it's about externalizing your thought process. Right. And getting a clearer picture of that logic flow before you even start writing code.
It's like doing a walkthrough of your code.
Yeah.
Before you actually start the construction.
Exactly. That's a great way to put it.
Catch those architectural mishaps early on.
Exactly. And then, once you kind of have that visual representation, that blueprint, the next step is to break down the problem.
Okay.
Into smaller, more manageable components. Right.
Okay.
So instead of trying to tackle, this massive complex feature as one giant blob of code.
Right.
Think of it more like, assembling a Lego structure.
I like that.
Each Lego brick on its own is relatively simple, but you combine those together, you can create some really impressive structures.
Right.
And so it's the same with code.
Okay, so we're breaking down our code into those modular Lego bricks.
Exactly.
What's the next step in building our code masterpiece?
So once we have those Lego bricks, right, the article really stresses the importance of defining clear interfaces between those components. So what that essentially means is making sure that those Lego bricks can connect to each other and communicate with each other effectively.
So it's like establishing, those really clear communication channels between like different teams on a project.
That's a great analogy.
If everyone's on the same page about, how that information is exchanged, things just run smoother.
Exactly. It makes it much easier to go back and modify things later on.
Right.
Without breaking everything else.
Yeah.
And then the last step here, which I think is something that often gets overlooked.
Okay.
But it is absolutely critical for writing robust code, is planning for error handling.
Error handling. It's like, that feeling when you realize you left your phone at home?
Right.
And you're like, oh, I'm sure it'll be fine. But like,
deep
down,
you're in for it.
Yeah, you're going to hit some snags.
Some headaches. Yeah.
Yep, exactly. And it's the same with code, right?
Right.
We can try to pretend that errors won't happen.
Right.
But, in reality, they're inevitable.
They're going to happen.
So the article really emphasizes this point. Incorporating that error handling from the very beginning, from the get-go,
okay,
is crucial. It's like having, a safety net for your code.
Right. So that if and when something goes wrong, it doesn't take down your entire application. It's about building in those safeguards.
Right. So it's not like we're going back and just like slapping on Band-Aids after the fact. It's like we're actually like building it in
from the ground up.
Yeah, those safety mechanisms. Yeah.
Exactly. And so the article, it actually goes into some specific techniques for this, right? Like using things like try-catch blocks to gracefully handle those exceptions, or implementing things like, error boundaries in your user interface to prevent, the whole app from crashing if one part of it fails.
So what I'm hearing and what I'm gathering from all of this is that, writing cleaner, more robust code, it's not just about like, memorizing the syntax and like the specific, Yeah,
it's a deeper...
It's this fundamental...
It's a shift in mindset.
Mindset shift, yeah. Okay.
Absolutely. And the excerpt, it actually takes that idea even further with, it uses this really cool analogy to fractals.
Fractals, like
yeah, like those mesmerizing...
Like infinitely repeating patterns.
Yes, exactly.
Okay.
So I know it seems kind of like, what do fractals have to do with code?
Right, exactly.
But the article makes this argument that good code often resembles a fractal in the sense that the same design principles that make for a well-structured application also applies level of like individual functions and modules.
Okay.
Right. It's about maintaining that consistency of structure and thinking across all those different levels of your code.
So it's like you're zooming in on a fractal, and you just keep seeing those same elegant patterns, but...
At different scales, exactly.
At different scales. Okay, I like that. It makes clean code seem less abstract.
Yes.
And more well-patterned. There's a pattern to it.
Exactly. And to help guide us in creating this kind of fractal-like elegance in our code, the excerpt dives into 4 fundamental design principles that I think every developer should have in your toolkit.
All right, let's dive into these principles.
Yeah.
What's the first one on our list?
So the first principle is the single responsibility principle.
Okay.
Or SRP, as it's often called.
Single responsibility principle.
Yeah.
Sounds pretty, it seems pretty self-explanatory.
It does.
But I have a feeling there's a little more to it than meets the eye.
There is. It's one of those things that's deceptively simple.
Okay.
But incredibly powerful when you actually put it into practice. The single responsibility principle basically states that every component of your code, whether it's a function, a class, or a module, should have one, and only one, clearly defined purpose.
So it's like that saying, jack of all trades, master of none.
Exactly. Okay. That's a great way to think about it, right?
Yeah.
Because if you have a function that's trying to do too many things, it becomes very difficult to understand, to maintain, to debug.
Right.
So by ensuring that each part of your code has this single specific job to do, you make your code base significantly easier to work with down the road.
So if one part breaks, you know where to look.
Exactly.
Yeah.
You immediately know where to go.
And fixing it shouldn't affect...
Right. And it shouldn't have these unintended consequences.
Yeah. Okay, that makes sense. What's the next principle on our list here that we should be aware of? Okay, single responsibility down. What's the next principle on our journey to code elegance?
So next up, we have the don't repeat yourself principle.
Okay.
Or DRY, as it's commonly known.
DRY. I've definitely heard that one thrown around.
Yeah, it's a big one.
So that's all about keeping your code concise, right?
Exactly. DRY is all about identifying and eliminating redundancy in your code.
Okay.
So instead of writing, the same block of code multiple times in different parts of your application, the idea is to abstract that logic out into a reusable function or a class or a module.
So it's like you're creating a code template, right?
Yeah, exactly.
Or like, if you're thinking about like in the kitchen, it's like your master recipe.
Right.
Once you have that base, then you can easily tweak it for variations, but you're not starting from scratch.
Exactly. And it makes it so much easier to maintain, right?
Right.
Because if you need to make a change, you only have to do it one place.
Right.
Instead of hunting down all those different instances of that logic scattered throughout your code base.
Oh, that's a recipe for bugs.
Exactly. It's asking for trouble.
Yeah.
So DRY principle, super important.